Hello, my name is Will Hathaway. I am a meteorologist from Austin, Texas, and I am here today to talk about how to protect your students from severe heat and related illnesses by utilizing the wet bulb globe temperature instead of the heat index. This presentation will be approximately 10 to 20 minutes long and is an updated version of my previous talk from last year. If you have any comments or questions, please leave them below or contact me directly. Here is a brief summary of my presentation points along with links to jump ahead in the presentation. Today we will cover what heat-related illnesses are, historical fatality data, excessive heat products, the differences between heat index and wet bulb globe temperature, the supporters of the wet bulb globe temperature, and how to measure the wet bulb globe temperature. This chart shows the 5 types of heat-related illnesses, symptoms, and treatments as classified by the CDC. Heat rash, the least severe, sunburn, heat cramps, heat exhaustion, and heat stroke. The CDC recently changed the standard definition of heat stroke to use a core body temperature of 105 degrees Fahrenheit instead of 103 degrees Fahrenheit. It is important to know that heat stroke requires immediate 911 attention. If heat stroke is not treated immediately, it can lead to severe brain damage and death. Heat stroke can be expanded into 2 classifications: exertional heat stroke and classical heat stroke. Exertional heat stroke occurs in individuals who engage in strenuous physical activities for a long period of time in a hot environment, such as athletics and marching band. Classical heat stroke commonly occurs in sedentary individuals not engaged in activities. Over the last 23 years, there have been 2,986 fatalities related to heat in the United States. As you can see in the chart, there are spikes in fatalities which correspond to widespread severe heat events across the United States. So, where do these fatalities typically occur? The National Weather Service has tracked the locations of these heat related fatalities over the last 23 years. Of the 2,986 recorded fatalities, 19% have occurred outdoors. This includes outside open areas, ball fields, camping, and golfing. It is important to note that this percentage could be higher since 16% of the overall historical fatalities are undetermined. However, heat-related fatalities in homes still remains the main location for heat-related illnesses. Since we are discussing Texas today, how does Texas compare? During the same historical period, there were 339 heat-related fatalities in Texas. You can see similar spikes in fatalities, which corresponds to severe heat events across the state. While most fatalities occur inside homes without adequate cooling, 22% of the heat related fatalities over this 23-year period in Texas occurred outdoors. So, what can be done to prevent future fatalities outdoors? First, have a heat safety plan in place and be ready to act upon it when necessary. In addition, monitor the temperature, exposure time, and hydration of students during events and practice. This is especially important for student athletes, marching band participants, and anyone outdoors. Make decisions on outdoor activities based on the National Weather Service excessive heat alerts and available heat indices. These heat indices include heat index and the wet bulb globe temperature. This graphic shows the National Weather Service definitions for excessive heat alerts. They are color-coded to show severity with excessive heat warnings and heat advisories requiring immediate action. The excessive heat warning and heat advisory are issued 12 hours in advance of extremely dangerous heat conditions. Excessive heat watches are issued 1 to 3 days in advance. Excessive heat outlooks are issued 3 to 7 days in advance. When an excessive heat watch or outlook is issued, you should consult your heat safety plan and prepare for the event so you have adequate lead time. As you get closer to the event, it is important to monitor the heat indices. The National Weather Service defines heat index as a measure of how hot it feels when relative humidity is factored in with the actual air temperature. The wet bulb globe temperature is a measure of heat stress in direct sunlight which takes into account temperature, humidity, wind speed, sun angle, and cloud cover. Let's look at the two indices in detail. This slide shows the mathematical formulas for both. As you can see, heat index is a very complicated calculation with several environmental constants. These constants are based on ideal conditions and assumptions, such as the average height and weight of a person, amount of clothing worn, core temperature, sweat evaporation rate, etc. The wet bulb globe temperature, in comparison, is relatively simple and sensitive to small changes in weather variables. Heat index is a measure of how hot it feels to the human body. It is based on measurements taken at a weather station in the shade with light wind, but this may not be relevant to your local conditions. Heat indexes can be up to 15 degrees higher in direct sunlight. In comparison, the wet bulb globe temperature is a measurement taken at your activity's location in direct sunlight. It is more comprehensive than the heat index because it is meant for physical activity and includes more weather variables. So how do we utilize these indices in decision making? The National Weather Service Heat Index Caution Chart shows the degree of caution needed at specific temperatures and humidity levels. These temperatures will give you an estimate of how hot it feels outside. However, it does not give you any specific recommendations to follow. Instead, it shows the likelihood of heat-related illnesses to occur at specific temperatures. In comparison, the wet bulb globe temperature chart shows specific recommendations based on the wet bulb globe temperature and activity level. The wet bulb globe temperature can change quickly, so it is important to measure it every 30 minutes to an hour, due to the fact that the wet bulb globe temperature is sensitive to small changes in weather variables. This chart is used by OSHA and the United States military for extreme heat planning. It shows the amount of work to rest ratio based on the heat risk, as well as the amount of water intake needed. However, this chart is not focused on student activities outside. The National Athletic Trainers Association worked with the Corey Stringer Institute of Yukon to create these recommendations using 3 regions called categories. This chart is based on the previous chart from OSHA, and it shows specific activity guidelines based on the wet bulb globe temperature for each category. As the categories increase, the threshold of each color level changes. While the primary focus is on football, it does include recommendations for all other sports. These recommendations should be used as guidelines for any other outdoor activity. As shown in the previous slide, there are different categories for heat safety. A football player practicing in 9 degrees Fahrenheit temperatures in Texas could be comfortable, but a football player in the same conditions in Maine would be experiencing the worst heat conditions of all year. As you can see, the categories are not tied to specific states or geographic regions. For an example, Pennsylvania, California, Ohio are partially in each of the 3 categories, and Texas has both Category 2 and 3. This shows the importance of measuring the local wet bulb globe temperature and knowing the category your activity location is in. The wet bulb globe temperature has been recommended by several organizations. These include the University Interscholastic League in Texas, which is the governing body for all student extracurricular activities, OSHA, the National Athletic Trainers Association, all branches of the United States military, the International Standards Organization, the USA Soccer Association, and the Corey Stringer Institute. This map shows states that require a severe heat policy. States that are in orange recommend the wet bulb globe temperature for outdoor activities. States that are in yellow recommend using heat index for outdoor activities. States that are in gray do not have a state-mandated heat policy and or preference on the wet bulb globe temperature or heat index. As I mentioned before, the wet bulb globe temperature is a highly localized measurement of heat risk. These wet bulb globe temperature meters can be obtained from different manufacturers at different price points. Some meters include more features than others. There are also companies that provide permanent weather installations and services that measure a multitude of weather variables, including the wet bulb globe temperature. The prices for the installation and services vary with the company. I have listed 3 companies that advertise wet bulb globe temperature monitoring as part of their services provided. However, if a wet bulb globe temperature meter cannot be obtained, an estimation of the wet bulb globe temperature can be calculated by using this chart. It is important to know that the wet bulb globe temperature is not a feel-like temperature like heat index. Therefore, the wet bulb globe temperature may be lower than the actual air temperature or heat index. It should be noted that this chart assumes full sunshine, no clouds, and light winds when calculating the wet bulb globe temperature. This estimation is not as accurate as measuring the wet bulb globe temperature at the location of the activity, but it is better than nothing. This chart must be used in conjunction with the wet bulb globe temperature recommendation chart previously shown to make heat safety plan decisions. In conclusion, to prepare for your outdoor activities, develop a heat safety plan and review it regularly. You must be willing to act on the plan when necessary. Communication between decision makers and those supervising students outdoors is critical. Be sure to measure the wet bulb globe temperature every hour at the location of the activity and provide adequate hydration. The wet bulb globe temperature is another heat stress index to look at for decision making. It takes into consideration more variables than heat index and gives recommendations for action. Thank you for the opportunity to share this information with you today. If you have any further questions, please feel free to contact me or leave comments below. My contact information is listed on the slide.